Hello folks, today I am going to share with you a process to identify and rank quality elements within your organization so that you can take steps later to improve them. This process is called FMEA, Failure Mode Effects Analysis. Okay, so failure mode effects analysis. This is a process to identify quality issues. That's the first step. And then rank those quality issues so that you know what are your priorities to work on first. It's a multi-step process. A little history here. Back in the 1940s, I think World War II timeframe, the United States was very interested in improving the quality of the war effort. And a big part of that, you think about the war effort, you have a lot of equipment. You have, weaponry. You have equipment such as vehicles. You have arsenals, right? All of these things, when they work properly, they're going to help your strategic efforts of achieving your goals. That piece of it, that the military having a vested interest in improving the quality, they developed this particular process, failure mode and effects analysis. And we use that today extensively in the field of quality throughout many different types of businesses. Whether you're making products, you're delivering services to your customers, this process can work for you. In my earlier video, see if I point the right way this time, the coffee pot analysis, looking at poka-yoking it. Think of the poka-yoke process of engineering in improvements. Later, we're taking a step back and we're going to look at what were those things that engineers did work on? Because if you think about it, they could have worked on a ton of different elements to improve a coffee pot, so much so that they may never actually deliver a coffee pot. So how did they identify and rank those priorities to work on to improve it so we have a safe coffee pot and I can enjoy that delicious morning juice? Let's go through the steps here. The first part, FM, failure modes. In this step, we are identifying all the potential ways that a product can fail. And you usually do this in a brainstorming type activity. You bring in people from a cross-functional segment of your business. You have people from operations, research and development, sales, accounting. You may bring some customers or potential customers into this type of arena. So you're bringing them in, and I will share with you a spreadsheet now. I've got the link below, and we're gonna bring this up periodically and fill it out as we go along. But one of those tabs on that spreadsheet actually is the attendance for the people who are involved in that brainstorming session. Critically important here. There are no bad ideas. If you've been through a brainstorming session before, you know that sometimes a bad idea will stimulate other ideas and eventually you might get to a good idea. But now you have all these ideas of how something might fail, how your product might fail. How do you rank them? So again, now with that brainstorming, documenting, listing all of these, that's our failure mode. That's the first step. The next part, effects analysis. This is where the rubber meets the road, right? We're gonna take each one of those elements that we came up with. In this case, for the coffee pot, if you remember, one of the ways it could fail is overfilling the reservoir. Well, that may have come up in a brainstorming session. Let's do the effects analysis on it. Now, effects analysis is broken up into three parts. We're gonna look at the severity of the issue, the occurrence of the issue, and the detection. Right, and each one of these gets a score of 1 to 10. In essence, let's break this down so we really get this. In essence, we're getting a holistic view of how bad this particular issue is, how often it can happen, and really, is it in our control or not? So those three, when put together, give us a much better view on a priority to figure out what do we work on next. Let's go back to my reservoir. We'll bring up that spreadsheet here. So when you have and fill out the sheet, if you look, the process step, I said it's the user brewing the coffee. In fact, all four of the ones we're going to talk about in the video came from that particular function. All right, potential failure mode. The failure mode identified here is overfilling the reservoir. Now that leads us to the next step, was severity. How bad is this on a scale of 1 to 10? On that spreadsheet, you're going to notice other tabs as well. One of the tabs actually has the identification or identifiers for each of those rankings for severity. In this case, we're talking about a safety issue that kind of is uncontrolled, right? We're not going to have an indication component to it. So from a severity standpoint, this is a 10. Now I ranked it this way. If you have a different viewpoint, absolutely, this becomes part of that discussion. There's no real right or wrong, but it's kind of a consensus. How does your team look at it? But I will share with you how I came to my conclusion. Severity-wise, if that water overflows, now if it's just sanitation and it's messy, you clean it up, that's one part. But think about it, this is a coffee pot that you've plugged into the wall, so now we have electricity and water together. Somebody might get hurt. So I rank this higher. Again, your own thought process behind how you rank it, you're gonna wanna come at this consistently as you rank each of your failure modes. Next, we have occurrence. Here I chose a 7, right? In terms of overfilling that reservoir, maybe it doesn't happen every time. This is really dependent on the user. And in this case, it could happen, it may not happen. So I put this in place that it's a user driven, so I didn't give it a 10 that it's gonna happen all the time. I also didn't say it's never gonna happen, or very rare that it's gonna happen. So I put it kind of in the middle here. That was my logic. All right, next we have detection, right? So in terms of overfilling the coffee pot, detecting this particular failure, it's going to be very readily detectable. You're gonna see the water overfill and go beyond where it's supposed to be. In fact, there's markers on the outside when it fills to where it's supposed to as well. So it's very visible to the user if they've made this error. So I've ranked the detection a 1 in this case. So now we have severity, we have occurrence, we have detection. We filled out the rest of the spreadsheet as well, right? For all the other categories, the other 4 that I'd listed. If you were doing this in real life, which I hope you will, you're going to then, again, take all of those ones that you came up with during your brainstorming session and fill your sheet out. Now, here's where the math starts to come in a little bit. We're gonna take our spreadsheet and we're gonna start making some assumptions with the numbers that we have. Okay, let's start with criticality. Severity times occurrence, right? How bad is it to how often we think this is going to happen? We're gonna take those 2 together, and that's gonna give us a ranking and a priority system to know, right, in terms of those 2 categories. We can also take all 3, severity, occurrence, detection, multiply them by themselves. We have that answer as well, and that's gonna be our RPN, or our risk priority number. Again, here, when we have these, it gives us a relative ranking now towards that chaos that came from our brainstorming session, now to something substantial to where we've ranked it. The next step, what are we gonna do about it? Once we have those priorities, we come up with an action plan to mitigate the risk on each of those. In the case of my coffee pot, go back to that video one more time and you're gonna see what those engineers came up with. I'm terming that poka-yoke, but it likely came from this process, FMEA.